Welcome to this exercise on calculating derivatives for functions with one variable. Here we have the following two functions for which we should calculate the first derivative each. So let's start with the first one. First one being f of x equal to x to the power of 3 times ln of x. Since we multiply two parts here and have to get the derivative thereof, we can use the so-called product rule. Product rule always applies if I multiply one functional part, which we could call g, with another functional part we could call h. And then we see here we always have to derive one of the two parts, leave the other part as is, do this the other way around, and in the end add both of those aspects up. So for this, I'm first going to note g as x to the power of 3, h as ln of x, and then calculate the derivative of both parts of this. Well, here we can use the simple function for polynomial terms. So we pull the 3 in front and subtract 1 from the exponent, giving us 3 times x to the power of 2. For the ln, we can just look up the derivative in the formulary, and then we will find the derivative as 1 divided by x. So we can get our derivative for this by just multiplying crosswise and adding up the results. So this times this plus this times this, giving me this part. So here I went with this times this, first part, plus this times this. And well, if I look closely, here I have in the second part x to the power of 3 times 1 divided by x. So here I can summarize them into x squared, making it a bit easier. Well, if I wanted to continue simplifying or factoring out, I could also factor out x squared. I'm not doing this at this point, but this would be one more step to make this maybe a little bit easier to understand. But this already is the first derivative of the part A. So we can take a look at part B. Here we have the more or less opposite situation. We have a fraction. We divide one function, x, by another function, 1 plus x. So whenever I divide one function by another, I can use for determining the derivative the so-called quotient rule. So I define the top function, the nominator function, as g, and the denominator function as h. And then this formula looks quite similar to the one from the product rule. I also go with one derived, the other not derived, but there's a minus in between. And that's why here the order which to derive and which to leave as is important as compared to the product rule. And well, finally, I also have to take the denominator function, square it, and put it into the new denominator of the derivation. Well, let's go about this. Let's determine g as the nominator, which is x, and the derivative of x is 1. Then, for the denominator function, we have 1 plus x. Derivative here as well, because this 1 is a constant, derivative 0. We also have a derivative of 1. And then we can go about building our first nominator by going this times this minus this times this divided by original h to the power of 2. So it looks like this. Well, then we can just factor out up here in the nominator, simplify it a little bit, giving us 1 plus x minus x, and in the end x and x cancel each other out, leaving just 1 in denominator divided by 1 plus x in parentheses squared. And thereby we also have the derivative of our second function of part B, bringing us to the end of this exercise, so that I can just say goodbye and see you next time.